Hello everyone and welcome to another Python video. Today we'll be working with the data type called sets in Python, and we're going to be looking at the three questions: removing duplicates in a list, finding unique letters in a given words, and we're going to be doing a set intersection counts, as in if we were to have multiple sets, how many values will we have intersecting with all these sets? Let's get started. So to start off, we're just gonna create a little function that removes duplicates by using list features. So we'll say r underscore duplicates like this, and we'll say that we have in a list like that. And here we're not gonna do anything special or crazy, but we're gonna just normally look through this a underscore list and see what we would have to do. So we would have to have a resulting list. Let's set that equal to empty, and then look through each individual values in our list. So we can say value a list. If value is not in result, we're going to say result.append that value. And after that is done, we can say return our result safely, and we can go end of our duplicates list. So if we run this code, let's say we want to see the print of our duplicates with providing, let's say, a list of 1, 2, 2, 3, 3, 3, 4, 4, 4, 4. What it would do is really just look at, well, it's going to give me one of each numbers that we have put inside our function. So let's execute that. Video 44.py. And that will give us a list of 1, 2, 3, 4. Now, this was a lot of work. In our future unit, we would say that, well, this is really inefficient because I'm now looking at each individual values in our list and also doing another search through our resulting list where I have to now search if this value does exist or not exist in the result variable. Okay, so we're doing two searches through lists, and as our data set gets bigger, this would be a very more of an inefficient task. Also, we're just writing a lot of code that where if we're going to write it this inefficiently, well, might as well do something much quicker, and that's where we're going to use a set version. So we're going to say this is our duplicates 2, and we're going to have a list. Okay, so what we're going to do is just say that we're going to have a set version, which is going to be running the set function on a list. So we're converting our a list to a set. And then we can simply just return the list version back because sets guarantee that we're not going to have any duplicates because each individual values in our set has to be unique. So now let's run this code. End of our duplicates 2. And honestly, this could have been even shorter, that we could have just done return the list of set of a list. So we're just doing some function within a function here. We're going to convert it to a set and back into a list so that we get our desired output, and we can our duplicates like that. Run our code, and we're going to get the same result as our first function. So if we know that we're going to do something this inefficient already, might as well do a set conversion and do convert it back into a list. This might be an easier way to write a duplicate remover, and also this would be indeed faster, not by a lot, but would be a faster version than this code here because we're not doing any if statements to check if a value exists. Rather, we're just converting to a set and just iterating to that set once more just to put it into a list. Okay, so that is our now little handy dandy duplicate remover by using the powers of sets, because sets don't contain duplicates. Every single value must be unique. Okay, so speaking of that uniqueness, we're going to now look at the second question here. We're going to find unique letters in our given word. So we're going to be given a bunch of words in a list, and then we're going to return a set containing all the unique letters. This is very simple. What we're going to do is say def unique letters, and we're going to take a list. And we're going to say that a list will contain strings of words. All right, so we're going to have our resulting set. It's going to be an empty set. Is empty set not this? because that is a dictionary. Okay, so we set an empty set here, and what we're gonna do is just really add these individual letters one by one. Okay, so let's do that. We're gonna say for word in a list. We're looking through each individual words, and then we're gonna create a temporary set is equal to set of that word, where we're gonna convert the string word into a set. And this is going to remove every duplicate characters and separate each individual characters in that string with only containing the unique individual different characters we might have in that set. And then what we're going to do is say that, well, after that, we're going to say result add that temporary set. So this is going to get resetted with all the words changing. And then we get to just add that. And if there are collisions, if there are duplicates adding in, that's okay. They will be intersected, and then we just forget about them because we are doing a union. Okay. So we can now just go actually, it will be much easier if we were to do union. So we can say result is equal to result union of temp set. This operator is union. We can also use if we wished. Okay. So the reason why I'm doing a union here, because this is going to be growing as a set, might as well join them together by using a union to say that, hey, we're going to take our previous result and union it with this temporary set that we continuously create, and then we can do return a result set. Okay, so that's the end of unique letters. And then we can say that we have a test list of hello, goodbye, world, Mr. Park. Like that. And then we can go see print unique letters of test. And if we were to run this code, local variables result. Oh, we want results set. Like that. So it's clear. Run this again. We're going to get all these unique characters, right? There are no repeats. And what we have is we have found that we have, we just have all these unique characters that are shared amongst all these words, and there will be no duplicates, but these are all the unique characters that were used to create all these strings. Okay, and that's the power of set. If once we convert it to a set, we are shrinking down each words to their unique characters, and then we're using our union operator to join these two sets together to grow a resulting set that's going to hold each individual unique characters from each string. And we don't need to worry about like, have we added it yet? Like, do we need to check? No, because even if we do a union and if there was a collision, like for example, we have O already added from hello, but goodbye can also add an O, it's not going to put in duplicates because our sets can only have single letters and unique values. Awesome. And lastly, what we're going to do is a set intersection count. We're going to write a function that takes a list of sets and returns the count of elements that are common to all sets. Alrighty, so we're going to say this is a, I'm just going to call it an I count, and we're going to have a list. A list contains numerous sets. Okay. All right, so we're gonna have our result set to empty again, empty set. And our goal is to continuously do an intersection. Okay, we're gonna continuously do an intersection, but I think to make our life easier, we're gonna do this instead of using an empty set. Actually, we're gonna say if a list. We're gonna go a list is going to be. We're gonna take our very first value, grab the first value from a list, and we're going to set it to result set, and then we're going to loop for a list. We're going to say for a we can say example set in a list from 1 onwards. So we already grabbed the very first set that is contained in our A list array. And now we just slice the A list so that we're going to start from the second list onwards. And we're going to be representing that by this temporary variable from our for loop called example set. And now what we're going to do is continuously update result underscore set with the intersection starting from the first one and onwards. So we're going to say result set. We're going to go is equal to result set, and the ampersand is the intersection operator with this example set that's currently changing. So is the intersection operator. Okay, like that. So we get to do that constantly. And after that is over, we can say return the length of result set. Length will, let's call that a function, will count how many values our result set has. So that's the value that we're going to return. So we can say end of I count. Okay, so in our testing list, now we're going to have maybe values of like 1, 2, 3. We can have 3, 4, 5. And then we can have 5, 4, 5, 6, 8, like that. Okay. Okay. So let's try this. All right, everyone. We're going to run this function again with our testing list right now with a set of 1, 2, 3, 3, 4, 5, and 5, 6, 8. We actually do have 0 values that exist in all sets, so we should get 0, and notice that we're going to get 0. All right, so that was a little silly mistake. So what I'm going to do is just put 7 and 7 and 7 here, like so, where 7 should be intersected from all of these sets, so that we should have at least one value that exists in all sets, and that's going to be our count, and we're going to get 1 here. Okay, that was a little silly mistake of me. It's working as intended. We're just going to continuously intersect each list one by one, and as long as we constantly have this repetition of a value that is consistently in each set, we should be creating a master intersection set by the end. And if we just find the length of it, we should be able to count how many values that were shared between all the sets that were given. Okay. And as always, thank you for watching and stay classy.